Question 3. A crate of mass 600 kilograms is being pulled up a line of greatest slope of a rough plane at a constant speed of 2 meters per second by a rope attached to a winch. The plane is inclined at an angle of 30 degrees to the horizontal, and the rope is parallel to the plane. The winch is working at a constant rate of 8 kilowatts. Find the coefficient of friction between the crate and the plane. I'm going to do a sketch here. This is my sketch. So we have the particle here. Then, of course, since there is power, then there is a driving force taking it up. Then there has to be frictional force because it's a rough plane, right? Then the angle of inclination is 30 degrees. See, now this particle here, first of all, it is on a horizontal plane, then its weight acts downwards. Now, when you tilt the plane, that means this one is also going to tilt the same angle. So it was here, now it tilts to the same angle. You tilt the what? The plane. You see that? Now we have to resolve this one here. So vertically, here, we have to close in. So closing is cosine if you have been following my videos. So this is mg cosine of theta, then opening is mg sine. So this one will be mg sine here. And of course, on any plane, there has to be what we call the normal reaction. So there is an arrow there. So meaning here I will have mg cosine. M is 600, then the G, then cosine of 30 degrees. Then there is normal reaction here. And then here we shall have 600 G, then sine theta. Okay. So that is that. There is something they said here. At a constant speed of this. So this simply implies that for constant speed, acceleration is always equal to 0. Now, power is equal to the rate of doing work. Work is force times distance, okay? Then divide by the time. But distance over time is speed. That's why we can write power is equal to force times the velocity, okay? So if it is 8,000 here, then the force here, that is the driving force, then times the speed is constant. They gave it to us as a 2, so put a 2 here. Now when we divide all through by 2, that means the driving force is going to be equal to 4,000 newtons. Now, of course, there is no vertical motion, so that means R is equal to this one here. In other words, by looking at the forces vertically, our R is equal to 600 G cosine of 30 degrees. And then horizontally, we shall use, since there is movement, using F, which is equal to MA. Then this F here represents the net force, okay? So we shall get this driving force, then minus the two opposing forces. We have mu R, then plus, I will actually just say minus 600 G, then sine of 30 degrees, then I will equate to MA, the mass here, but then times the acceleration, which is 0 due to constant what? Speed. So this will be 0. Now, this is 4,000 minus mu. Our R is 600 G cosine of 30 degrees, then minus 600 G sine of 30 degrees, which is equal to 0, okay? So I will actually take this one to this other side, and then it becomes a positive, okay? Now we shall have 4,000 minus, here we are having 600 times 10 times the sine of 30 is a half, then equate to mu. What is here? This is 600 times 10, then times cos of 30 is root 3 over 2. So meaning we shall have 4,000 minus, this is 6,000 divided by 2, that will be 3,000. Then we shall divide by what is here. So 6,000 divided by 2, that is 3,000. So we shall have 3,000, then square root of 3. That will be the value of mu. So what will this one be when it is simplified? Of course, this will be 1,000, then divide by 3,000. So this one then will be 1 over 3 root of 3. I can say times root 3, then times root 3. For SADs, we don't write them in the denominator. But even if you leave your answer here, no problem, they give it to you. So this one here will actually be root of 3. And this one will give us a 3. So 3 times 3, that will be a 9. So meaning mu in its exact form, whatever I written, this one is supposed to be a 9 here. So mu is going to be root of 3 out of 9. That is that.